To begin the machining, the model area clearance tool is used. This will machine up to the inner profile of the brake disc. The block area is then created. To do this, the calculate button was used. An axis system was then placed in the centre of this newly created block. The calculate button was used again to place a disc into the block. However, as the disc is a circle, it had overhangs on each of the edges. To make the disc a perfect circle when it is machined, we had to increase the block size to 185 by 185 millimeters. When the part has been machined, we needed to make sure that the tool would come in from the correct direction. To do this, we needed to swap the X, Y and Z axes so that they were the correct way. The swap axes tool was used to do this. The block then needed to be recalculated so that the brake disc would be the correct orientation when we came to machine it. The size of the block also needed to be changed back to 185 by 185 millimeters. The tool then needed to be created. A diameter of 6mm was used for this. The software then calculates a suitable length for the tool. The tool path was then changed so that the lead-in was ramped. This tells the tool to ramp in instead of trotting straight down into the block. To simulate the toolpath, the Simulate from Start button was used. This set the machining process to the beginning. The speed of the process is adjusted with this slider. The animation is then started and the toolpath is being generated, as you can see from the video. The next task was to create a drilling process to drill all of the venting holes. To do this, the drilling process is used. The same method as before is used to create the drill bit. However, the only difference is the drill is selected from the drop-down menu. As the holes are all 4mm, a 4mm diameter is used from the drill bit. To select the holes that need to be drilled, a feature set is required. All of the individual holes are selected, and this feature set is then chosen for the drilling process. The toolpath can then be seen, and the same simulation technique as before is used to simulate the whole process. The View Simulation toolbar is used to change the toolpath simulation to a 3D block where the machining process can be seen. In this instance, the profile of the disc is generated first. However, as it is a basic 2D shape, it doesn't matter which order the machining process is, whether that is the profile or the drilling first. The feed rates for both of the processes were changed to a suitable value. A safe rapid move height of each tool was then changed to 5mm above the surface of the block. The NC program is then used to write the G-code for the machine path. To create this, the Write NC program feature is used. The toolpaths are then dragged and dropped into the NC program. Once the program has been written, the view program can be used to view the G-code that the software has generated. The G-code was then imported into a program to check it. The software used was Simco. This then generated the toolpath. As can be seen from the video, the toolpath was originally incorrect. This was because when Powermill generates G-code, occasionally it creates R- when it should just be an R. To fix this, the find and replace function was used. Everything with an R- was then changed to just a regular R. This then fixed the toolpath, and the correct toolpath can now be seen.